My friends and followers, allow me today to speak about plastic recycling. This is a subject I return because there are always some aspects that are new or I would like to stress, to underline. So just let me share. It's just one picture presentation. I have to find here, share the screen with you. And okay, this is the picture I want to share with you. And this was published in Nature. And I think it's a very good a very good art describing the process. So I'm talking about plastics. And plastics, the orange of plastics is, as you know, is fossil. So coal, oil, and gas. Coal, gas, and oil, and oil. These are the feedstock, the raw material for the plastic production. From this material over naphtha, and then the derivatization of naphtha, the base chemicals for plastics are produced. And since there are many plastics, there are also many base chemicals. But most of the plastics, I think over 80%, especially those that cause problems for us, they are so-called polyolefinic plastics. And polyolefinic plastics, the base monomer are ethane and propane. I want to remember from chemistry lessons, ethane are 2 carbons and propane are 3 carbons. But this is the unit, the moiety. Now, those materials are sold to or taken over by polymerization company. They are called plastic converter, and they are polymerized plastics, polymerization, plastic chemical company. Like the big one, no big oil. They polymerize. And by polymerization, you create a very long chain of these units. The units can be 2 carbon or 3 carbon, but the end product will have something like 60,000 carbons and above. So very long chain. And those chain of carbon, they are basically composed of only 2 elements. And the elements are carbon and hydrogen. That is why those feedstocks are called hydrocarbon, because that is the composition of the oil, the fossil oil. The composition of coal is only carbon, and the composition of natural gas, which is methane, 1 carbon and 4 hydrogen. But basically, all of those processes they contribute carbon or carbon and hydrogen. And during the process, you do add some more hydrogen and come to the plastic. So plastics are very long chains of carbon, and each carbon carries at least 2 hydrogen. That is, by definition, what they are. After the polymerization, the plastics are delivered in form of beads, small beads, and those beads are taken over by so-called plastic converter, and they are manufactured. And the manufacture can be films, can be bags, can be jugs, can be bottle, well, many things. Look around you, you see lots of plastics, and they all comes from the different manufacturing process, and also different base chemicals can be used. But then you have the plastics, and of course you use the plastics. Unfortunately, most of the plastics are used only once, single use, and that is the very nature of the plastics. But after the use of plastics, they become, of course, residue, waste, you name it. And then there are a few options what you can do with it. There are certain cases that the plastic can be reused, and if you can reuse a jug, reuse a film, or reuse a plastic bag, that is what you should do. Do reuse them, because that is the best and the energy most conservative way. But of course, if not, you're going to throw away these plastics, and the plastic comes to some municipal solid waste, a waste collector, if these servers are available in your community. In the advanced countries, of course, they are. And then you have the collections. For the collections, a few plastics is lost, by the process. But what has happened with most plastics waste that are collected, they are sent to incineration or landfill. Landfill is forbidden in Sweden, so in Sweden we don't have this problem, but incineration, we do have incineration. A very small fraction of the plastic collected are reused, but a very small fraction can be reused because most of the plastic here, they are contaminated by food, they are blended, they are mixed plastics, and you cannot reuse with the initial purpose. So reusing of plastics is very limited. So the plastics from the waste, which are not incinerated, which are not sent to landfill or even illegally, but not from Sweden, of course, exported to some third world country, they are sorted. And there are some material lost when you sort the plastics. There are, and unfortunately, there are some microplastics coming out of that. This is very serious. Need to recognize, need to handle that. But those sorted material is material for recycling. And this is the first mistake because a lot of people say, oh, this is the recycling. From here to here, it's not recycling. From here to here, you are preparing the material for recycling. But preparing for recycling is not the same as recycling. It depends on what we do. Now, a lot of material here are used for fuel and energy. That's waste to energy. Waste to energy is, of course, not recycling. You are just burning the material. When you burn, you are producing CO2. So you have some emissions here, which can be very problematic. Many countries and cities, they don't want to have this process, but this is recycling. Now, for recycling, you do have some options. There is the options of mechanical recycling that you will just press the plastics and re-extrude it as new plastics here. So directly the mechanical recycling. I have to tell you that mechanical recycling has a very limited possibility, especially if the plastics are blended. Mixed plastics will not go well with mechanical recycling because there will be phase separation. And also all the contaminants that were not sorted out that are included in the plastics, no, adsorb to the surface of the plastics, they will come to the plastic again. So these plastics has normally lower quality and cannot be used by the original purpose. They are not to compare with virgin plastics. So mechanical recycle is interesting when you can do, you should do, but bear in mind there are some limitations. The other is physical recycling, where you break the plastic to its monomers and can remanufacture new plastics. This is, in certain cases, possible. There are technology there to break the plastics into its monomers, and then this can be used when this is possible, is a very good option. The third option is the one of chemical recycling. Well, chemical recycling, there are at least three different technologies. There is solvolysis, which is dissolving the plastics and precipitating it again. This is more in the physical procedure. They're very limited application, but there are two applications that are commonly used, and this is pyrolysis and gasification. Well, pyrolysis, you produce three phases: a gas, a solid phase, and a oil and pyrolysis oil. And if you can use this pyrolysis oil to fish out the monomers and do repolymerize, that's a very good option. But be aware, pyrolysis is by no means a simple thing. The pyrolysis oil contain all the homologous series of plastics. And this goes from C1, the carbon, to C32, the wax, and every same mixture. So more often than not, the pyrolysis oil cannot be purified, or the purification of the pyrolysis oil is too expensive. I hear a lot that the pyrolysis oil is equated to naphtha. Well, this is not the case. Naphtha is something. Naphtha comes from the fossil oil, from the distillation of fossil oil. Pyrolysis is something else. Naphtha has a much smaller distribution And the reactors for naphtha, they are very specific producing naphtha. They are very specific. They don't take pyrolysis oil because pyrolysis oil is too complex. So very often, more often than not, the pyrolysis oil will end incinerated. And this is something that I am very critical, because why should you take all the cycle up to here to burn? I say burn here. You can burn, collect and burn the plastics. No, you can do that all the time. We know that. And this is, of course, if it's burning you want, there is no reason why go all the work, because you are losing energy here. You are losing energy. You are taking the thermodynamic cost of doing this. It makes no sense, in my opinion. Now, last and not least, gasification. Gasification has been around for 200 years, and different types of gasification. The gasification of the state of the art is done at very high temperature, very high pressure, and gasification break the plastics molecule to its monomers, to its constituent, molecular constituents, and the molecular constituent is carbon and hydrogen. So this is the way of producing carbon and hydrogen, and then you can repolymerize. But at very high temperature, this process, there's no way to make this process economically feasible. And that's the reason most of the people, when I say incineration, they say immediately, oh, that's high temperature, high pressure, no economically. That is true. Most of gasification are of this case. But we have, since many years, developed the technology of LTC, low temperature conversion. And low temperature conversion is gasification done at low temperature and a normal pressure, which is economically feasible. So we have developed an economical feasible process to bring the plastics to its new units, because this carbon and hydrogen, the syngas I'm talking about, is now renewable syngas, because there is zero participation of fossil in it. It is totally coming from the plastics. This, in my opinion, is the best way to deal with plastic waste. Thank you so much for that.